In this problem, look at a specific example of Simpson's paradox. We're given 4 jars. The 2 on the left collectively labeled as C, so we have C1, jar C1 and jar C2, and the 2 on the right, jars M1 and M2. So C1 contains 7 green gummy bears and 8 red ones. M1 has 1 green, 2 red ones. C2 has just 5 green gummy bears, and M2 has 12 green ones and 5 red ones. So we can see that the proportion of green gummy bears of C1 is larger than that of M1. C1 is 7 out of 15. M1 is 1/3. And the proportion of green gummy bears in C2 is 1, which is larger than that of M2, which is 12 over 17. But as Simpson's paradox states, as can happen when we aggregate the total number of gummy bears in the C jars and we aggregate the total number of gummy bears in the M jars, and when we look at the proportion of green gummy bears in the aggregate jar now, we see 12 over 20 versus 13 over 20 for the M jars. So the aggregate C jar has a smaller proportion of green gummy bears compared to the aggregate M jar, even though the individual C jars had a larger proportion of green gummy bears compared to the individual M jars. So this is exactly an example of Simpson's paradox. And the way we can understand this is we can imagine that it is more difficult to sample a green gummy bear from jars that are indexed 1 versus jars that are indexed 2. And because the C1 jar has a lot more gummy bears, a lot more green gummy bears than M1 does, the C1 jar sort of does the heavy lifting. Whereas most of the green gummy bears for the M jars are in M2. And as we said, we can imagine that sampling a green gummy bear from M2 is a lot easier than sampling a green gummy bear from C1. Now, to sort of formalize this and write this example in terms of Simpson's paradox, we can let A be the event that a sampled gummy bear is green. So let A be the event that sampled gummy bear is green. And we'll let B be the event that the jar being sampled from is one of these M jars. So B is the event that a gummy bear is sampled from M1 or M2. And we'll let C be the event that the jar being sampled from has subscript 1. So C is an event that a gummy bear is sampled from C1 or M1. So a jar with a subscript 1. So then Simpson's paradox tells us that the probability that the sampled gummy bear is green, given that we're sampling from an M jar, given that we're sampling from an M jar, and it's indexed 1, is smaller than the probability that the sampled gummy bear is green, given that we're sampling from a C jar, and it is indexed 1. So we verified that. We said that 1/3 is smaller than 7 over 15. So this statement's true. And the probability of the sampled gummy bear being green, given that we're sampling from an M jar that is indexed 2, is smaller than the probability that the sampled gummy bear is green, given that we're sampling from a C jar that is indexed 2, which we also verified because 12 over 17 is smaller than 1. However, the probability of getting green gummy bear, given that we're sampling from an M jar, not specifying which one, but rather the aggregate M jar, is larger than the probability of getting a green gummy bear, given that we're sampling from the aggregate C jar, which we also saw in this example because 13 over 20 is in fact larger than 12 over 20. So this is how this specific example fits in the context of the Simpson's paradox.